So welcome everyone to our tall mass timber discussion. We're going to be looking specifically at prescriptive design today. But before we dive into that, we have a few guests with us that are new to mass timber or maybe new to us. So I just want to introduce WoodWorks and our WIN community first. WoodWorks is a nonprofit organization. We're funded by the softwood industry to provide free technical support and project assistance, specifically for larger commercial or multifamily wood frame projects. We help developers, engineers, architects, contractors, and even installers. Now, we actually have some training programs in place for training installers, specifically on mass timber. We also help with light frame projects and heavy timber construction as well. But today we're talking mainly about mass timber. You can find all our resources on woodworks.org. You can use our search function to maybe search for something better than that. To search for any specific topics that you have in mind or that you're looking for more information for. You can also use our ribbon to access some of our other resources, such as educational resources or tools that can help you with your projects. We also have events listed on here. So our presentation archive includes all of our past presentations in PDF form, including the presentation you'll see today. And then upcoming events are listed here. These include all of our online and in-person events, and it includes the Mass Timber Conference, which is coming up at the end of March. This is an international conference. So if you're interested in mass timber and you want to meet a lot of other folks who are also interested in mass timber, this is a great conference to come to. If you're looking for direct project support, this is one of our main functions. You can come here by clicking our Need Project Support button. Type in your zip code, 97205 is Portland, and that'll take you to your local regional director. So I am Kate Carrig. I am the regional director with WoodWorks for Oregon, Southern Idaho, and Hawaii. If you happen to be in my region, you can contact me directly by my cell phone or by email, or you can fill out the form down here. But please do feel free to contact me directly. I'm a very friendly person. We also have all of our staff on our website. So I'm joined by regional directors all across the country. If you aren't in my region, you're still in good hands because our regional directors all have industry experience. A lot of them are engineers, and we also have architects on board as well. And we are all supported by our solutions team. So these are the people that are putting together all of the resources on our website and all of our presentations. Now, if I can get Zoom out of the way. So this event specifically is for our WoodWorks Innovation Network, which is kind of a side initiative we've been working on. This was created because we realized that by supporting projects all across the country, we had developed this strong network of professionals who are all experienced with mass timber and with innovative wood construction. And rather than leaving that in some sort of database that only WoodWorks could access, we wanted it to be online and public so that everyone could actually access that network. So the members of the WoodWorks Innovation Network are all people who have experience on successful projects. You can browse them by going to Find a Pro, or one of the better parts of our website, or the most popular one, is this interactive map. So this is a map that allows the members who have joined to actually show their projects that, again, are successful. These are projects that have made it through design, they've made it through permitting, and they're breaking ground in construction, or they have already started construction, or they are built. You can actually filter this website by a bunch of different categories, including tall mass timber. And you can see where these projects are. You can access the projects by either clicking on the pins, or you can select them from the list. So today we will be talking about TimberView. You can find Timber Views projects. So this is information that the team has compiled about this project on the WIN network. And you can also find the team members themselves. If you want to look closer at the team, the members that are part of the WIN network have profiles and you can contact them directly. Because again, the point of this is to just foster networking within this community. So this is a really great tool if you're an experienced professional and you want to gain more exposure. And it's also great if you are new to mass timber or you're starting a mass timber project and you're trying to look for more information or to assemble a project team. One of the most recent additions to this website is our supplier and manufacturer directory. So these are our partners that support us so we can continue to provide free resources. And these are specifically our industry partners that you see here. You can contact anyone on this list by going through this directory. So with that, let's get back to our presentation. In addition to our industry partners, we are mainly funded by the Softwood Lumber Board, the U.S. Forest Service, and then also Forestry Innovation Investment. And we are a registered provider of continuing education with AIA. So we've actually registered this conversation as a course in order to allow all of you to gain AIA continuing education credits. So you'll get 1.5 credits at the end of the discussion. I'm not going to read all of the learning objectives to you, but I'm happy to send you that information if you want it. We will be talking about prescriptive design, and specifically we are talking about the International Building Code. So this is a code that's updated on a 3-year basis. We're currently in the 2021 IBC, and mass timber first occurred back in the 2015 IBC. But back then it was only really recognized as an acceptable product that you could use in any of the wood frame construction types that were in the code at the time. So we could only build about 4 or 5 stories, maybe 6, if you did everything right and had an occupancy that allowed for that. Despite those limits, though, there was still a lot of interest in going taller back in 2015. We were seeing all these tall buildings appear over in Europe, overseas, and up in Canada. And then there was also a competition held by the USDA and Softwood Lumber Board here in the United States to help spur more research and more interest in these tall wood building types. So a couple of the entries for that competition are shown here. Both of these were from Portland. We had Carbon 12 and then Framework. Framework actually won some of the grants, the funding for this competition, which went into the research they had to do to develop their design. They did go all the way through permitting, but the building fell through because of investment. Carbon 12 wasn't a winner, but they were able to build this building. So this building is available in Portland if you want to go tour it. So based on all of this interest in tall wood construction, the ICC, or International Code Committee, decided to form an ad hoc committee to actually investigate the feasibility of these tall wood building types. And then they were charged with performing any further research that needed to be done, and then drafting the actual prescriptive code provisions for review. So as part of this initiative, they performed 5 full-scale tests on 2-story mass timber buildings, and they looked at a combination of exposed mass timber, gypsum-covered mass timber. They also looked at buildings that were sprinklered, and they looked at the effects of delayed sprinkler protection as well. And they used the results of those tests to develop these 3 new construction types. So they also used any other research that had been done up to that point to inform these as well. The main differences between these 3 new construction types are the fire resistance ratings required for the structural members, as well as non-structural members, and then the amount of timber you're allowed to expose. So these are all mass timber buildings. They range from 85 feet or 9 stories up to 270 feet or 18 stories tall for the tallest construction type, which is 4A construction. For C construction, you're allowed to fully expose all of the timber on your ceilings and walls. And for A construction, you have to have everything concealed. For B construction is a little unique because they allow you, or they have limits as to how much timber you're actually allowed to expose, and those are shown here. So it's pretty limited. You're only allowed to expose up to 20% of your surface on your ceiling or 40% of your wall surface. And then you can do combinations of those. So if you want to expose both, you have to trade off some of that area to expose your walls and vice versa. And then if you expose multiple locations, you can still only add up to a total of 20% on the ceiling or 40% on your wall. So the reason for all of the protection on the ceiling is tied to a performance characteristic of our older version of CLT when it's applied in a horizontal application like in a ceiling. So this is known as char fall off. It's something that occurs when your protective layer of char actually peels off the bottom of your ceiling during a fire, exposing a non-charred layer. So that gives the fire an opportunity to start to regrow and eat up more fuel. This was largely a function of adhesives and the performance of adhesives under high temperatures, but through testing, they were able to generate new standards for adhesives used in CLT that were able to withstand these higher temperatures much better. So we addressed this in the PRG 320 2018 version, and the 2021 IBC does include provisions that require you to conform to that standard. So this is something that was addressed in the 2021 IBC. However, the tests that the ad hoc committee performed were performed on CLT that was fabricated using the older generation of adhesives. So that's why, again, there were so many limits on how much of the ceiling you could actually expose. But there was a lot of desire to expose more of the ceiling. And because we had updated the standards for the adhesives we used in our CLT panels, the American Wood Council teamed up with a number of interested parties and performed new tests, again, 5 full-scale tests to see if we could increase that exposure limit. So for the 2024 IBC, based on those new tests, you are allowed to expose up to 100% of the ceiling for that type 4B construction type, and you can trade off that exposure in order to expose some of your walls as well. So looking at, who has actually adopted these codes across the country, Oregon is way ahead of the game. We have adopted the 2024 IBC provisions, so we are allowed to expose 100% of ceilings in our type 4B structures. Washington has also decided to do that, and theirs will go into effect in July of this year. Idaho and California have not adopted the 2024 provisions yet, but they have adopted all of the 2021 tall wood provisions. So as a whole, the West Coast and the Pacific Northwest are, way ahead of the game when it comes to these tall wood types. So before we hand it over, I just wanted to give you some fun statistics about where we are with tall wood construction. Mass timber in general, as of December of last year, we had over 1,600 projects that WoodWorks was aware of. 12% of these projects are tall mass timber projects. 44% of the tall mass timber projects started in 2022. And again, that's because of these new provisions. If you look at the actual heights of all of these tall mass timber projects, 87% are 12 stories or less. And that's because people really want to expose that mass timber. It's one of the major market drivers for this construction type. If we look at this by occupancy, 73% of tall mass timber projects are housing projects. And you can see that in this slide that we made in November of last year. So these are all the buildings that were in construction as of last November. Ascent in Milwaukee is the tallest mass timber building in the world. It is not based on these prescriptive types, but it's pretty cool to look at. It's 25 stories tall with 19 stories of mass timber. Intro was actually one of the first prescriptive building types. It's a type 4B building in Ohio. And on the West Coast, in addition to Carbon 12, we had 3 buildings back in November under construction. So Heartwood, up in Seattle, Washington, which is a 4C, Minnesota Places, which is here in Portland, also a 4C, and then 1510 Webster down in California, which I believe is a 4A. And we have members of all of these team on the call today, or at least people were invited. So pretty exciting. And then the other exciting news is that, again, we get to update this map with a few new projects, including Timberview. So with that, I'm going to hand it over to the Timberview team to actually present on their project. So David Burnett of Access Architecture and Shirley Chalupa of DCI Engineers are going to take it over.
Thanks, Kate. I'm actually going to do a brief intro and then I'll pass it off to the team. So my name is Brendan Sanchez. I'm principal at Access Architecture and appreciate you all spending an extended lunch hour with us. We're happy to share what we've learned from this project so far. And I know a lot of today is going to be focused on Q&A and discussion. So we're going to kind of go through these slides quickly. It's really more of an outline of some of the discussion points that we may want to touch on, but we're going to leave a lot of time at the end just for some general discussion. So if you have questions, definitely ask those once we're through these slides. I guess I should read the disclaimer at the bottom there that this presentation was developed by third party between Access and DCI and is not funded by WoodWorks or the Softwood Lumber Board. So here are the presenters we have today. In addition to myself, we've got David Burnett from our office, who's been the project architect and really doing the heavy lifting on the design side, on the architectural side for us. And then we've got DCI engineers, Shirley, Justin, and Kevin, who've been just really integral to this project and a really good resource for us to lean on as we have taken on our first mass timber project. Just real quick about our firm. We're fairly new. We're in our 5th year, so still kind of an emerging firm, but we bring staff with a lot of expertise in multifamily and commercial. We have a kind of a wide range of project typologies, but our mission really is around designing connected communities. So we're kind of a mission-based firm and try to imbue those values in every project that we do, Timberview included. This is our small but mighty firm. See there? Next. All right, I'm going to pass it off to David to go over an overview of the Timberview project and some of the specific challenges and opportunities and lessons learned that we've come across so far.
Thank you, Brendan. Now that you have met the team behind it, I want to introduce you all to the Timberview project itself. Timberview is an affordable housing mixed-use project providing 105 units and roughly 2,600 square feet of retail space. It is developed by C&J Property Development and being constructed by TrueBreck Construction. We are utilizing the mass timber provisions adopted in Appendix P of the 2019 OSSC to build a prescriptive Type 4C building. And so that's essentially that Appendix P kind of pulled in that 2021 code that Kate was talking about earlier. So that was what allowed us to use this prescriptive code in a 2019 code cycle. Timberview is 8 stories above grade with a basement and mechanical penthouse. This is the basement floor plan with laundry, bike, and tenant storages and service spaces. On the ground floor, we have the retail space in the southwest corner, which is upper left on the page. This faces the intersection of 99th and Gleason. The TI space will be developed as a food hall with 4 food vendors and a bar. Additionally, the ground floor has entry lobby, offices, some amenity spaces, and back of house elements. The upper floors house the residential units ranging from studios to 1, 2, and 3 bedroom units. The studios and 1 bedroom units are contained within 1 structural bay, whereas the larger units span multiple bays. As you can see, we opted to align the structural grid off the demising walls to better allow for plumbing stacks to run through them. The top floor is similar to the typical floor, except for the addition of the community room and deck community room and deck with views of Mount Tabor and even downtown Portland in the distance. I'll pass it off to Shirley to introduce the structural system.
Sorry about that slight glitch on the technology. Hi, my name is Shirley Chalupa. I am principal at DCI Engineers. I would like to do a short intro to DCI. We are a structural and civil engineering service company, and we are located 17 offices throughout the United States. So I'm managing principal at Portland office, and we have been in Portland for over 28 years. And we also have done 80 mass timber projects throughout the United States. So with that, I would like to go back to how the project was originally conceived. It was longer than 4 years ago when the owner came and reached out to me about their desire to help solve Portland housing crisis. That was one of their original goals, but also they're very passionate about sustainability and how to achieve design using sustainable materials. So they also shared some of their concerns, especially the construction affordability. It's an important portion of that to make sure that we come up with a system that makes sense and actually works and also affordable. Speed to market is also something that is desired because especially due to the housing needs in Portland. So we landed on 3 systems currently that we basically studied previously, and we assigned some kind of scoring for each goal, so which one that actually has the highest scores. And it turns out that mass timber actually wins all the criteria there, as you see in the table. On top of that, there are also additional challenges that we have on site, especially the small footprint, and it is located at the intersection of really busy major streets. We have neighbors located adjacent to the site as well. There's noise and disturbance also a concern. The biggest challenge that we ran into is actually the soil. The soil bearing pressure is so low, 1800 psf at grade, that if you have a heavier system, then most likely we will end up with deep foundation. So because we are using mass timber system, 30% of the weight for instance, a concrete frame structure that we're able to essentially design spread footings and grade beams to actually support the building. And because of the less foundation and less excavation, that means, we also help with the cost, reducing the excavation shoring costs on that in that situation. The photo that we show on this slide here is one of the example that we also experienced on one of our projects in Seattle, where the project's also located at the corner of busy streets. There's not much room for staging. As you can see there is only, we could pretty much just have only half a lane for a delivery truck to come and deliver the material. So very similar situation here. And actually, it turns out that, this solution makes sense for this site. So essentially, the takeaway from this slide is that mass timber project could be making sense, especially if you have all these issues that we're running into, plus there is sustainable component. And if your project goal is to meet sustainable design, then mass timber would be a good fit for your project. So I will give it back to David.
Thanks, Shirley. Now I'd like to discuss some architectural items relating to mass timber that came up during design, permitting, and construction that should be planned for as soon as possible. Type 4C allows full exposure of wood structure. However, that may not be the most cost-effective approach, as it often requires upsizing the members to account for a 2-hour sacrificial char layer. Early in the design, it was determined that for our project, it was more cost-effective to provide 3 layers gypsum wallboard, wrapping the columns and beams, than to upsize them to account for the char layer. A determination that could easily vary between projects, material, and labor markets. We optimized the use of the exposed structure and its aesthetic by highlighting the beams and columns at communal spaces and when the structure is within the unit and not when it is tucked near the periphery walls, where we opted to cover them. Code requirements determine some maximum and minimums for the height of timber view. Type 4C allows for highest roof surface to be 85 feet, whereas a mid-rise structure is limited to 75 feet to highest occupied floor. This, in addition to some zoning stipulations, gave us a floor-to-floor height of 9 foot 10 inches to work with. This results in maximum beam depth ranging from 1 foot 7 inches to 2 foot 1 inches, typically fine for many construction types, but glulam beams with a sacrificial char layer can readily exceed that depth. Compound that with the needing mechanical venting to cross structural bays, head clearance is something that requires careful consideration and design effort in mass timber construction. Of course, there are ways to alleviate these concerns, but they need to be integrated in the design very early in the project, such as utilizing the 2-way spanning capability of CLT and allowing to remove the beams entirely, reducing beam spans and therefore depth, explore high-rise and type 4C construction types, or using an alternate beam system entirely, for example, steel. Because glulam beams and columns provide all of the structure, the exterior and interior walls need to allow for deflection. On this project, the worst case condition is plus or minus 1 inch deflection for a total 2 inch of travel. Unlike many other construction types, rated walls join directly to the exposed structure of the CLT decking while needing to maintain that fire rating. Wall ceiling intersections cannot be concealed or covered in gypsum wallboard or a drop ceiling, as is common in other construction. Therefore, careful detailing and innovative products are needed to deal with these conditions at the interior and exterior. Mass timber design is rapidly evolving. Despite the project falling under prescriptive code path, the code, engineering, and jurisdictional viewpoints progressed as the project underwent design development, construction documents, and permitting. For example, We chose the structural hanger supplier early in the project because that manufacturer had the most complete available documentation at the time. During permit review, the AHJ determined the documentation insufficient. By that time, another manufacturer had more complete documentation. We could either redesign the structural system with the new hangers or work with the previous manufacturer to provide an engineering judgment that would appease the AHJ. The DCI team will go into another example in more detail later. However, to briefly state it here, the project aimed for prescriptive path with no need to file appeals. The novelty of this construction type and the reviewers being unfamiliar with the intricacies of maintaining fire rating at numerous connection types resulted in us filing for an appeal for fire rated protection at connections. The AHJ did not have a path that would allow for us to proceed 100% prescriptively due to the gray area within the code and reports. As one last example that I will discuss here, being a residential project, floor ceiling assemblies are required to have minimum sound performance rating. During initial design, we contracted a sound engineer to provide a viable assembly meeting the code requirements and project needs. During bidding, it was determined that an alternate assembly would be required as the gypsum underlayment manufacturer would no longer warranty their part of the assembly as it increased thickness of their product, was needed to avoid cracking over CLT construction. Furthermore, additional testing by another manufacturer also showed prior lab testing from which our sound engineer started as basis for his design was redone in August of last year and showed the initial tests were overly generous. A new assembly had to be found, but within the depth and weight restrictions already designed into the project. And with that, I will pass it off to the DCI team to discuss some structural considerations.
Thanks, David. I'm Justin from DCI Engineers, Structural Project Manager. If you want to move on to the next slide, I'll talk about the gravity system. So gravity system for the Timberview project, starting with the floor assembly, we had a 5-ply 6 7/8 inch thick E-series CLT floor system with a V-series at the roof. We have a 1.5 inch thick gypcrete topping over the CLT. And then at the ground floor, we have a mild reinforced concrete slab, which is over the basement area. We also have slab on grade adjacent to the basement at grade. The CLT is supported on a series of glulam beams that clear span across the double loaded corridor. So interior corridor wall to exterior wall. Those glulam beams are approximately 16 to 18 feet on center, essentially aligned with the demising walls of the units. Typical sizing for those 8 3/4 inch width and approximately 25.5 inch deep. They utilize Raycon concealed hangers as the typical connection of varying sizes. We also have steel wide flange beams at the second floor for a couple cantilever conditions, as well as where required at the typical floors. We also have glulam columns, the typical sizing 14 1/4 wide by 16.5 inch deep. And we transfer out all the columns at the ground floor over the basement, and they're supported on concrete columns that run down to the mat foundation at the basement. Just kind of, I have a couple diagrams here. So starting at the top left and working counterclockwise, we've got a recent floor model that we use to do initial sizing for beams and columns and track loads all the way down. And then at the bottom, a couple of framing plans. So we have our typical floor framing plan, as well as a CLT panel layout. And then in the top right, it's just a snapshot of our typical beam to column connection. So with that, I will pass it off to Kevin from our team, and he's going to talk about fire and lateral.
All right, great. Thanks, Justin. So in mass timber construction, there's an inherent relationship between fire rating and the structural design. So for type 4C construction, the beams, columns, and panels are all 2-hour rated. And this rating was achieved with 2 methods on this project. The first of which is gypsum protection, where 3 layers of 5/8" gypboard, each providing 40 minutes of protection, are used. And this is part of the prescriptive provisions in the 2021 IBC. The second method used was char of the exposed mass timber, and this is prescribed as a calculated method in the NDS, which is the wood design code. So beams and columns used a combination of both these methods based on the needs of the project, kind of like what David touched on earlier. And the 5-ply CLT panels achieved their rating solely from char, which allowed for exposed CLT ceilings throughout the project. So for connections, as mentioned earlier, the Rikon conceal hangers were used for all beam to column connections. Diagram on the bottom left corner shows an example of this detail. And so for member connections, the 2021 IBC contains fire resistance rating requirements that are based on limiting temperature rise. And part of the benefit of the concealed hangers is that the wood cover at the end of the beam inherently contributes to this connection fire protection. So the analysis used to verify the connection fire rating was based on AWC's TR10. And the city of Portland was amenable to this approach and worked through it with the design team, although they still required an appeal for some of the provisions that lacked a specific path of compliance. And so along with that, an engineering judgment letter from the fire step product manufacturer at the connections was used with the analysis of TR10. Next slide, David. Thank you. So a little bit about the lateral system of the building. So Portland being a high seismic region, seismic design requirements will typically govern the selection of the system. And so for an 8-story building, which is on the taller side, current code provisions, current code prescribed systems are either going to be steel or concrete based. For example, like a steel brace frame or a concrete shear wall. And so buckling restrained brace frames were selected for a variety of benefits they bring, mainly being their high ductility, flexibility in system layout, and speed of construction, specifically compared to like a concrete shear wall system. So for the structural diaphragm, the CLT panels themselves were designed as the structural diaphragm, which means that an additional structural concrete topping slab wasn't required. CLT diaphragm design provisions are relatively new and are part of the 2021 wood lateral code, which is adopted as a reference standard in the 2021 IBC. So technically it wasn't adopted by the city of Portland at the time, but they allowed the use of these provisions. So other elements that are part of the CLT diaphragm system are flat steel plates and light gauge steel straps for elements such as cords, collectors, and panel splines. And all of these elements can be concealed in the non-structural gypcrete topping. The floor plan on the bottom left shows the general locations of some of the brace frames and strap elements of the diaphragm. And that's it.
Thank you all for listening to our presentation. We have provided our contact information here on the slide. If you have any questions or want to discuss anything with us outside of this presentation. However, we are going to run right into a Q&A session. So I'll kick it over to the WoodWorks team to lead that.
Great, thank you, David. If you want to stop sharing your screen, we'll open this up. So we're going to invite everyone to, unmute and turn on their cameras. sorry. Right, so everyone can unmute and turn on their cameras. What we're going to do is basically open this up to a discussion about Tallwood and with Timberview as like a case study for this as well. We tried to keep attendance small so that it wouldn't get too out of control. But just to make sure that we're not talking over each other, go ahead and, physically raise your hand or use the little hand emoji if you want, and I'll look out for raised hands to call on you. We do have all of the members of the Timberview team that you heard speak today. And then I'm looking for
We also have Mark Kobe here from Trubeck Construction to answer some of the questions on that side.
it looks like we have a few people who are not able to share their video, Jamie and Mary. So Dean Lewis isn't able to share. Chris.
All right, thanks.
There we go. We got you. All right. So we were expecting Mark Kobe. So Mark Kobe from Trubeck is also here. So we have someone from the construction team as well. And then I am joined by Ricky McLean from WoodWorks from our technical team, who I'm sure has plenty of questions for Tallwood as well. So we expect this will be a very engaging conversation. So with that, I will open it up.
Thanks, Kate. I'll go first, break the ice. Thanks all for sharing the project. It's a nice one. And I guess one thing I'm curious about is, like you mentioned, a lot of things have developed in the mass timber market construction over the last few years. Is there anything like that you'd start out differently with at this point, or you felt like it was all just bumps on the road? And
I think Mark might be able to speak with this a little bit, but in running the cost analysis of exposure of the mass timber, I think when we ran it the first time and made the decision, the wood market was pretty bumpy in terms of the costs. And so I'm not sure, maybe Mark can talk a little bit about it, but I think there would be more opportunity to expose more of the columns and beams now than there would be when we kind of locked it in earlier.
Yeah, David, I think that's pretty accurate. When this project was in the depths of design, the wood market was at its peak. So that's the nature of that decision. I would suspect that if we were to make the decision again today on the drywall fireproofing of the beams and columns, that calculation might have been a little bit different. I haven't specifically looked at that, but I would suspect that. But just in terms of the overall cost of the project, and Shirley touched on this a little bit earlier, if you compare this project to a PT deck concrete project to get to the 8 stories, particularly in this location where the soil pressures are not great, we have a much lighter structure, which significantly reduced the foundation costs. I think what's interesting between mass timber and PT, the superstructure portion on PT is probably a little bit of a cost savings, but it was offset by the added cost of the additional foundation requirements. So for this particular building site, how we wanted to go, this is really a pretty good fit cost-wise as well for the goals of the project.
So Mark, maybe I was going to ask this question to Shirley, but maybe this falls into your bucket now, but there was a mention of comparing steel and concrete and mass timber. But did you also look at a hybrid system like a stick frame 5/3 or something?
Well, we did look at every single system, but I think the 5/3 was not part of our study. We did look at 6/2 with CFS bearing wall system. That system turned out to be the most expensive one, especially since the contractor who can actually perform steel slab bearing wall system is there aren't that many out there. So I think that system also turned out to be the least sustainable compared to steel frame, because the material that's a process of making the CFS studs are actually require a lot more energy intensive than basically rolling out the steel beams. So we end up with just a 3 major system that we basically thought could still be within the sustainable material desirement that the owner has. And so basically between steel, concrete, mass timber, what pushed us over the threshold there, and mass timber wins all the category is the sustainable portion of that.
Thank you. I was figuring you must have cracked some sort of magic here, because you don't have to look too far around the Northwest to see most of these buildings are stick frame, which is surely an economic driver. So it's great.
Yeah, I mean, I think I would just add on to that. When looking at general contractors that were a right fit for the project, we had interviews with other general contractors who rightly recommended we look at a 5/2 scenario, and it was just a non-starter for our client. They were committed to doing mass timber and want to do an 8-story mass timber project, and Trubeck came on board and said, yeah, we can do that for you, and gave us some costs to work with. And so I think that's the commitment on the ownership side to mass timber is, I think, a large factor, knowing that if we were just looking at dollars as the bottom line, a 5/2 might pencil out better. But for, like what Shirley said, with the sustainability component that our clients really committed to, as well as the benefits of exposing the mass timber, those were just things that added value that didn't necessarily, plug into a pro forma spreadsheet.
I was curious about that. So maybe in terms of overall project delivery, Trubeck was brought on from day one, and then when was the decision made we're going timber, and then when was their engagement with subs and suppliers, and is there a timber installer as well? And maybe talk about that. That'd be really helpful.
Yeah, so Trubeck, we came on board, I think it was January, maybe December of 2022. At that time, yes, the owner did make the commitment already to go with mass timber. The first thing we did procure was the mass timber. So we landed on a partner, I think by February or March. And then later on that year, we selected our mass timber installer as well. So there is early involvement from those trades, just given the level of coordination that's required.
And did you permit for a specific supplier, or did you keep it ambiguous? It just needed to be Douglas fir or pine, or how did that work out?
We didn't have a specific supplier selected. We just specified based on the generic PRG 320 panel specifications.
So who is your supplier for this project?
Supplier is Kolesnikov.
I was curious on the timing of the permitting and the specific choice for type 4C construction. So I think, David, you mentioned it was permitted under the 2019 OSSC, which pulled in the appendix, which was basically very similar to the 2021 IBC provisions. But as Kate mentioned, there's now within the state of Oregon, the 2024 IBC allowances. So if, and I guess I'm asking you to project forward, but if the allowances had been in place to go up to 12 stories with fully exposed timber, do you think that would have been of interest to the client? Like, I think you mentioned they were kind of thinking from the start an 8-story building, but was that more kind of based on the 85-foot height limit, or was it just the number of stories they wanted?
So there was 2 stipulations that kind of locked us in at kind of that 8 stories. One was the type 4C, and then I think the other was the difference between mid-rise and high-rise construction. So we really squeaked out every inch that we could at the mid-rise construction, not hitting that 75 feet to lowest occupiable floor. And those stipulations going into high-rise are not insurmountable, but it was just not something that we were budgeted for or that was really in the pro forma. So it's that's where we kind of capped ourselves out at.
So this is an affordable housing project, right? And we noted in our statistics that the majority of these tallwood projects are multifamily projects. Do you think this is actually feasible in terms of what cost has been looking at so far for other affordable housing types? Or what has been the feedback from your developer on that?
I think one of the, well, so with affordable housing, it's always an advantage the more you can prefabricate elements of the building, because you're not having to pay prevailing wage for work being done on site. So I think that's one advantage to mass timber on this project is some of that fabrication can happen in a shop and it gets delivered to the site. I do also think there's probably more of an appetite for well, for example, this project is partially funded by the state through tax credits and a couple of other finance sources. I think there's more of an appetite to try to push the envelope on design and construction and multifamily development when we're looking at affordable housing versus market rate. So I think those components maybe help when you're talking about multifamily and specifically affordable housing for mass timber. I don't know if that really answered your question. That's just kind of what came to mind though when you asked it.
Well, it definitely added some information to the question. I would say we get asked a lot about whether or not mass timber could work for affordable housing, and it sounds like maybe there's some more grants and other funding opportunities tied to the innovation side of mass timber that can look at as well.
Yeah, for example, the state of Oregon has what they call LIFT funding as one channel of funding sources for projects, and it's the acronym is like low income, innovative, and fast track housing. So there's an emphasis on the fast track component, and the schedule compression that you can do with mass timber makes for a compelling application for that funding source. So that was one source of funding that was leveraged for this project on the finance side.
And Brendan, if I'm not mistaken, I recall that one of the other grants was tied to the density that could be achieved on this parcel of land. So that kind of goes into the 8-story that it achieved this density threshold or this density threshold to where a grant was available. And that was also, the mass timber was kind of tied to that 8-story as well, in terms of project height and achieving the number of units that they were looking for.
Gotcha.
That might have been, and maybe you're referencing the Metro Transit Oriented Development grant.
All right. Well, maybe we look more into detailing, or more into the code provisions. One thing I was wondering, were there any code provisions tied to the new type 4 or type 4C specifically, that ended up being a little bit of a gray area, where, you know, you found that the jurisdiction had an unusual interpretation or something like that? I know you mentioned the hangars as being one area that tripped you up.
Yeah, DCI, do you want to take this one? I think there was more gray area in the structural side than the architectural.
Yeah, I was going to say the one that jumped out on me, and we mentioned it in the presentation, was particularly the fire rating protection of the connections. While the 2021 IBC has requirements for connections to have a fire rating, how you actually do that is not very straightforward. And so that involved a little bit of back and forth with the city, so to make sure that we were all on the same page.
I'd have to say that well, the city didn't have a prescriptive way for us to kind of address these concerns. They were very amenable with us and very active in trying to get this building approved. So they worked with us quickly, and we had financing timelines to meet, and so they were a great partner in this project. We just needed to be able to get on the same page where they could sign off on something with certainty, because there just was not necessarily the certainty that they needed within the code.
Eric, you had a follow-up question?
Yeah, Kevin, I was curious, did you end up with intumescent caulk or intumescent tape at the beam to column connections?
Yeah, we ended up with like an intumescent strip product around the Raycon hangers.
I have a question about the intumescent. Were you in conversations with the supplier about how the intumescent materials would be compatible with the glues and the glue lamps and CLT? The chemical compatibility. Is nobody else scared of that? I'm scared of that. No?
I will say that we
Doesn't
did
freak you
talk to
out?
the supplier of or the manufacturer of the intumescent strip product and talked through the specific application of it. And they helped back us up on the use of it in that specific application.
This is a bit into the weeds, but now that we're on the topic of fire rated connections, could you explain a little bit more, Kevin, on the actual process for designing those connections for fire performance? Was it essentially a calculated char thickness as a cover, and then because of the use of the intumescent tape, you didn't have to consider like a char contraction?
I think that's a pretty good way to summarize it.
Okay.
Yeah, the AWC TR10 is actually fairly specific about like how much either gypsum board or wood you need to cover your connection to achieve a specific rating. But then, like you mentioned, there's some kind of gray areas about char contraction and how much that needs to be taken into account and what products you can use to mitigate it. And that's where the intumescent strip came in, and the supplier of that helped us.
Great. Thank you.
I guess continuing on that, did you have a fire engineer on board, or was this more of just a conversation with the city and proving out the analysis and getting it to work? You didn't need any engineering judgments, or how did you go about that?
David, you want me to take this one or continue on this one?
Yeah, I mean, yeah, I think it's just a continuation. Go ahead.
Yeah, I would say I don't think there was a specific fire engineer on the project involved, but the manufacturer of the intumescent strip did provide some engineering judgment letters that were used in conjunction with the analysis to help make the city comfortable with the approach.
Yeah, and I would add to that that ECI did an amazing job partnering with us and kind of providing a lot of the fire protection requirements and designing that into the building. This, as Shirley said, they've done a lot of mass timber projects in their past and their experience. So that was something that we leaned on quite heavily and really appreciated that they brought to the table.
It looks like we have another question from Eric.
Yeah, and this may have been mentioned already, but in terms of the fire rating on the CLT, did you do a calculated method, or were you relying upon manufacturer fire ratings or fire testing?
Yeah, the fire rating for the CLT was based on the calculated method in the NDS.
Ben, you had a question too?
Yeah, I have a sort of a broad question for everyone, really. Well, first of all, thank you for the presentation, and the building looks really great. But sounds like really it was the will of the client that after really made it happen, there was a strong commitment there. So I'm looking at whether there are still in your minds barriers to a more widespread adoption of CLT. What would those be? Is it economy of scale, having a whole industry set up around it? Are there still code barriers? The new code seems to have simplified or at least clarified things. But I think you talked about the weight advantage, and that's a good one. And perhaps there's a lot of advantages in the speed of construction and offsite construction and all that. But at the end of the day, I think, to me, the biggest barrier is cost when compared to other methods that was mentioned, 5/2, et cetera. So what in your mind are still barriers to potentially more widespread adoption of CLT?
I can start out, and I think everyone can kind of chime in on this subject because there's a lot of different facets. But I think one barrier would just be some unfamiliarity. I think from the developer standpoint, just kind of the uncertainty of the new. I think that's one aspect that is a little bit of a barrier, and the more people that we have in meetings and seminars like this, I think the less new and scary it is. So I think we're working towards that. But I would say that's one of the biggest ones I see.
I would add on to that supply. It's still somewhat a new construction type in the US compared to other countries. And 10 years ago, we barely had any manufacturers in the US, but as demand has increased, we've also seen an increase in the number of suppliers in terms of manufacturers, and also the number of different types of mass timber products we have available. So I think that's something that, as more people start to build with mass timber, now that it is in the code, we're going to see more and more manufacturers come in to catch up with the supply side based on that demand.
Yeah, I would echo that. I mean, I think even as you heard in the presentation, the available product data and products changed from the beginning of this project to when we went in for permit. So as the industry continues to advance and there's more products available to choose from and more data for those products, I think it just will make it easier and easier and more streamlined to get these projects designed and permitted and built.
Yeah, I think part of it too is just a matter of time. Like, this is a very to both of those points, it's a very rapidly growing and evolving industry. Some of the project numbers that Kate mentioned in terms of like mass timber projects, but specifically tall mass timber projects, we're at about 200 right now in the US total that we're aware of and assisting on. 14 months ago, that number was about 80. So, in the past 14 months, that has more than doubled. And I think all signs are pointing to that continuing to be a very steady increase in the future. Pair that with the fact that, Shirley mentioned the client initially approached them with this project, I think you said 4 years ago. So a lot of it is just these projects take time to evolve and grow. And so I think it's just that overlap of how projects of a scale like this take some time to work out, as well as the fact that the industry is rapidly growing and evolving. I think it is somewhat inevitable that trajectory is going to continue. It's just not going to be overnight, shoot way up, but it has been a very quick growth.
Yeah, I would like to add also is the inflation, the construction costs has been going up. We have seen a lot of developers come to us and asking for out of the box solutions and be creative and come up with all ways to basically make sure that whatever system that we end up with would be the optimized solution for their projects.
We have a question from Tim.
Yeah, I'm curious for the DCI team. I think David said you're using, or somebody said there were 16 or 18 foot centers on the glue lamps. Like typically when most of our CLT stuff, we've looked at 10s or 12s. What does that do to the structural system? Do you have a lot more movement, or do you just have thicker panels, or what's the aggregate effect of that?
Yeah, so obviously we try to optimize the unit layout. So and in that we also optimize the CLT panel. So the 5-ply CLT E series, we basically maximize that for fire, vibration, and that kind of helped determine that glue lamp layout, and then that kind of rippled through for the sizing of the glue lamps and columns and all the way through.
Is there any specific drawback to using that wider spacing and spanning more with those panels?
Other than, I don't think so. I think the layout actually worked out pretty well, that we kind of maximized just about everything. We kind of maxed out the CLT, the hanger connections were basically kind of at the limit of what they could do. And so obviously you get slightly bigger glue lamp beams, but the location of them was basically at the demising walls. So it was a lot easier to kind of hide those. And then where we couldn't hide them, we expressed them. So I don't think there was necessarily a drawback to that spacing. It just kind of lended itself to the unit layout, and we just kind of optimize off that.
Yeah, Tim, and what I would add is typically when we're at that 10 to 12 foot spacing, we're probably using a 3-ply panel and trying to minimize the wood fiber. And once you need a fire rating, then you need a 5-ply panel anyway. So then you start maximizing what's the 5-ply span for that, service level cases. And then typically it'll work out for the fire load case. So I suspect that was probably part of what drove it as well.
Yeah.
And just to add one more comment on that, the layout that was mentioned of the beams going beneath the demising walls, if you introduce some additional beams within the unit, it would have or in the corridors as well, it would have further complicated MEP coordination. So that layout did optimize downstream construction as well.
Yeah, I was curious, Mark, if you got any feedback or comparison for price for the E-rated versus the V-rated CLT panels, because I think that's where you start pushing those spans. You have to go to that E-rated, which gives you a lot more capacity, but it's a little more selective on the lamp stock, right? So, are you seeing like a huge cost impact for that, or not?
I don't know the answer to that. I would have to research that a little bit.
Typically around 10%, Chris.
Okay.
That's what we're seeing. And some of the manufacturers have a lower rate E-rating, and so they might be on the 5% premium range, but that's what we've been hearing.
Nice. Yeah. So that, yeah, that helps your MEP rating and gets your units to be the right size. That's gonna be good investment.
So what about your acoustics? Because acoustics can also impact your panel thickness as well. What is your floor assembly for your acoustics?
So as I discussed in the presentation, we actually had to pivot the floor assembly post permitting based on what information we got back from bidding. But the resultant application or the resultant assembly is flooring with integrated sound mat, a 2mm sound mat underneath that, an 1.5 inch of gypcrete, and then a 3/8 sound mat, and then the CLT, 5-ply CLT, 6 7/8.
What's the target STC for that floor style?
We were going for the code requirement and just aiming for 50, which is based on the project requirements and stipulations or pro forma. That's kind of where we needed to hit. We couldn't really go higher on that.
Yeah, I would say that's one of the lessons learned or things that we would do differently next time was we'd do 2 inches minimum of gypcrete instead of 1.5 inches. But by the time we got the updated testing data from Maxon, the additional 1/2 inch of gypcrete would have had structural implications, and that tracked all the way to the foundation. And we'd already placed an order for our mass timber components, and so it was one of those where we're just kind of like razor thin on the edge there of meeting code, but definitely wouldn't want to cut it that close next time around. So we would recommend adding a little bit more gypcrete to start out with.
Gotcha. So you placed your fiber deposit pre-permit approval. Is that right? Is that what you're saying?
I think it was actually the hangers was the most, correct me if I'm wrong, Mark, but I think it was the hangers that was the most time sensitive, which then we had to know what our mass timber components were.
I think that's correct.
Nikki, you have a question?
Yeah, just a quick follow-up on STC ratings. Below for that assembly between your roof deck, and I think there were units below. Were there any special considerations for STC ratings there needing to be a little higher than the typical unit to unit?
No, that did require a different assembly just because of the buildup there. We still needed to meet the 50 IIC and STC, but it did require an entirely different assembly just because we weren't able to lean on the sound mats because we had pavers on pedestals for the deck, and that sound transfer just wouldn't pencil out. So that in that one unit, we have a drop ceiling, providing some additional acoustic properties.
Oh, got it. Thank you.
I'm curious if there's any considerations in terms of construction sequencing with the assembly with that Dagwood sandwich of an acoustic assembly. Mark.
Can you restate that question?
Sorry, it's a little loud here. Are there any considerations in terms of construction sequencing with that acoustic assembly?
I mean, it would go up the same way that would typically be done in terms of the acoustic assembly, the same way that would typically be done for typical wood frame construction. So our walls go in, then mat, then gypcrete.
Yeah, I mean, I would say again, it's not ideal to have the various layers of the sandwich that we have. It was kind of one of those, we have to maintain a certain weight of our floor assembly. How can we get there without, adding additional cost or re-engineering? So the various pad layers between the LVT and the pad under that, like, we probably would approach that differently. That's just what allowed us to get to where we needed to be without having to do a redesign.
So I guess similar to sequencing, and then I'll let Chris ask his question, but similar to sequencing of that acoustic mat, the fire code also requires protection during construction. So once you hit 6 stories, you have to start protecting, putting in your floor protection and wall protection. But I know Washington has adopted an exception for mass timber floors that you don't have to specifically protect mass timber floors as part of that. What are you guys doing? Have you had that conversation with the city? I guess, Mark.
Yeah, so in terms of the drywall protection of the beams and columns, that is on our schedule. That sequence starts first, so we start that ahead of kind of the building being topped out. So there's only a certain number of floors exposed at any one time. As far as the CLT protection, I'd have to follow up with the project team on what we're doing there.
Okay, yeah, because that non-combustible would typically be the drip rate as you're going up, so that impacts your sequencing there. Chris, did you have a question too?
You took the question out of my mouth. I was going to ask him.
Maybe just to mention on that topic too, that is also one of the 2024 IBC code changes, is that you still have to have the non-combustible floor topping, but it's not required to be installed in that sequence. So if the cities, I'm not sure if you're still having those discussions or it's already been settled, but that might be something that you could leverage with them, is the fact that the 24 code, which they're currently on, but not at the time of permitting of the project, doesn't require that in that sequential order.
Well, and unfortunately, sorry, not to go off,
but go ahead.
What the OSSC did in the 2022 OSSC is it took the limited number of the 2024 provisions about exposure of type 4B and brought those into the 2022 OSC. It did not adopt the fire code, the 2024 fire code that has a vision. So you kind of get talking with your code officials who are like looking at your building permit, and then the fire official could be in a totally different wavelength. So it's just another discussion. We're interested to see how that's being navigated in Portland. And I think it's going to evolve.
That's why I was curious too, because like Chris said, the fire code didn't adopt that, but Washington did.
Yeah.
So it's interesting that Washington's fire side was so far ahead of their building code side, but then Oregon's opposite.
Yeah.
David, you might be able to speak to this better than I can, but does type 4C actually require the non-combustible floor covering? I know like 4B and 4A do.
I'd have to, I'm not familiar with any. I know there's the beam and column aspect of it, but
yeah, because I know in my head, I'm always thinking about, for that fire protection during construction, as really only applying to like the gyp board on the beams and columns.
I know that the city.
I can speak to that.
Okay.
Yeah, in my understanding of that that provision, that the 1-inch non-combustible protection between floors for 4C, B, and A is required, but it's different. That's different from the floor edges on the exterior of the building during construction.
So you're talking about the exterior wall protection, Susan?
I think the question regarding was the floor, the top of the floor slab.
Oh, gotcha.
In permanent construction, but I think there's potentially a confusion between, or maybe I'm confused about the floor in final in situ versus the edges of the floor as slab is exposed during construction. And that was not addressed specifically in the code that I'm aware of, unless there was some amendments in Seattle, as you referred to.
Yeah, I don't know that I've seen provisions for that either.
And looking back at type 4C and the 2022 SSC at least, it doesn't have that provision for the 1 inch minimum non-combustible floor topping. So type 4B does and 4A, but not 4C. So that's probably a provision that wasn't, although this project was maybe looking at a code earlier, so maybe I don't know exactly what the language was, where it was at, but that might not be a hurdle that they're having to deal with.
Yeah, that's one thing to remember with that during construction requirement is you're only required to put in that protection where it is required for the final built condition. So anywhere you are exposing, walls and stuff as part of your final built condition, you don't have to protect those during construction. Dean.
I had something that you and Chris kind of spurred my memory on, and I was curious for the project team here. Was there anything, because I remember instances where you're talking to the building department and then they would stop you and say, no, you got to talk to the fire department about that. And there was sometimes a gray area convolution on who was responsible for, what scope. There's like the fire egress and there's the connections and all these things that kind of cross populate each other. I was wondering if that happened at all in this project.
Yeah, so one of the times that the time that we had to file for the appeal, I think really what the question was about was just trying to get all of the people in the city on the same page, in the same room, talking about the same element. And that was really the impetus for filing that appeal, is what they told us, is there was no way to kind of get everybody talking and approve it without some appeal process where jurisdictionally and red tape wise, it got everybody to agree. So that was kind of the ultimate reason why we filed for an appeal, was exactly that question.
Mark, I'm curious, one thing that we've heard is a challenge on some mass timber projects is builder's risk insurance. And I'm curious if you encountered any, if you've gotten to that point yet, or what the status of that is.
So that's a good question. Truebeck on this project, we're not carrying builder's risk. The owner is carrying that. We did give them the information so they could quote it through their carrier. But they didn't relay any challenges back to me with that quote that they got from their carrier.
Okay. And what is the schedule timeline for timber being on site?
So we broke ground just recently in the last couple of weeks, and it is, I believe, June when we start going vertical, June or July.
Right. So I guess if you're starting in June or July, where are you at in terms of, I guess, finalizing your model and stuff with Kolesnikov?
So I'm not the BIM guy, so I'm not sitting in those meetings myself, but I believe, and Brendan and Shirley, you might be able to comment on that further. I believe we're through that process, or mostly through it.
So we're coordinating with Truebeck, not Mark specifically, but we're coordinating with Truebeck to get some submittals reviewed. And they are also coordinating with the MEP for penetrations, looking to finalize those. So we have the overall geometry approved and ready to go, and now we're just kind of getting into the smaller and smaller details, penetrations and things, and the routing of fire tape scenes and everything like that. So that'll get further and further refined.
Is there a lead time that Kolesnikov gave you for like, this is how much time between when we get the final and when we can actually fabricate the panel?
Yeah, there was a there was a general schedule that you know they wanted to work towards, and we wanted to work towards when we reviewed the proposal, in terms of first addressing dimensions, and you know then from there going into fabrication, developing a fabrication model. So our schedule is set up in alignment with what with their process as well.
I got one more, Kate. I was wondering if the design team, David, if you could talk a little bit about just any other considerations with your MEP fire sprinkler systems in coordination with the mass timber exposure that you wanted to have, that you could speak to, or any coordination with structural. Like, I'm curious, like fire sprinkler solutions, redoing sidewalls, things like that.
I would say that one aspect is obviously wanting to expose the CLT structure. You are going to end up with more exposure on your fire sprinkler lines or your electrical conduit, or some aspects like that. So those are something that we're reviewing with a close eye, and trying to, instead of having a drop ceiling that's hiding all of this stuff, we're trying to really hone in and clean up any weird angles or extra paths or weird T's. So we're just trying to make it as pretty as possible, as clean as possible.
Yeah, I think one of the precedent projects we looked at as far as interior spaces go is the canyons. So I think that's a good example of how you can expose some of those elements, but try to be intentional with where they're located so it doesn't look weird. I will say probably the most challenging area was the entry lobby, because we've got units above, we've got a lot of plumbing drops, and we've got HVAC equipment. So we had multiple coordination meetings with the MEP subs, and kind of nudging them to keep reworking the layouts until we got as much stuff off to the side as possible. And then what we did have to have exposed looks nice and clean and orderly, and not like a bunch of spaghetti string dropping down below the ceiling. But I think that was probably one of the more difficult design coordinations, was that open lobby area with units above.
And I think just building on Brandon's comment, one of the challenges with mass timber today is that it is new. So when you're circulating the project among your potential trade partners and getting pricing for fire sprinkler, mechanical, and even some of the architectural trades, not everyone really understands at this point that the ceiling is ideally exposed for its aesthetics, for its beauty. So it's up to the general contractor and the bidding process to make sure that each trade contractor, when they're proposing on this, understands that requirement, that yes, your installation will be exposed. Yes, when the painter is painting the walls, he can't have overspray onto the CLT deck. A lot of these guys are simply new to mass timber.
Did you see any premiums in subs because of that, or did you see any discounts in subs because of the pre-cut MEPF and all that?
I think from the mechanical MEP side, I think there is probably a little bit of a premium. I don't have any data offhand what it would be for this project compared to a typical 5/2 wood framed. But But there are some additional challenges in terms of routing, through the decks, fire stopping them, and leaving everything exposed.
Okay.
Just curious, with this being an 8-story building, but specifically having the steel brace frames for the DCI team, was there concern for or any unique detailing of vertical shrinkage, vertical settlements, those types of things just in general, but also relative to the elevations of the steel?
Yeah, so I will say that it's something that we looked at a little bit, and it wasn't a huge, it didn't look like it was going to be like a detrimental thing. But I wouldn't say that we took any extraordinary measures in the design to really accommodate significant differential movements between those two.
Yeah, I mean, I think what we found is that the beam to column detailing is the most critical in those conditions, and the details that you showed in terms of vertical grain orientation, continuous bypassing beams really minimizes the vast majority of that movement.
Yeah, absolutely. And I mean, that's part of the reason that when we looked into it, it was pretty minor.
Yeah.
If I think going to, like, you guys have a solutions paper that talks about, the differential movements, and you talk about the challenges of doing like continuous beams with columns, sandwiching those. And it's pretty clear to see that for a really tall building, that's almost like not an option.
All right. Thank you, everyone. And thank you to all our speakers today from the Timberview team. We really appreciate your contributions. This will be posted. It has been recorded. And so this conversation will be posted to help other teams working on projects as well.